Good morning, students. How are you? I hope all of you are well. Last time we have done the 3D, and today we have to start the new chapter, that is linear programming. Linear programming. First of all, you have to say this: surviving in an island. Suppose you will be left in a desert island. You want to live as many days as you can go to increase the chance of rescue. Fortunately, you can take a bag with you to the island. What would you put into the bag? Surviving in an island, the bag can carry at most 50 pounds. There are limited set of items you can carry. There is bread. You can survive for 2 days with 1 pound of bread. Steak. You can survive for 5 days with 1 pound of steak. Chicken. You can survive for 3 days with 1 pound of chicken. And chocolate. You can survive for 6 days with 1 pound of chocolate. And how much of each item to take with you? Think about this. And linear programming will save you. He tells you how many things you have to take with you. What is linear programming? The word linear means relationship which can be represented by a straight line. That is in the form of ax plus by is equal to c. That means it describes the relation between two variables which are proportional to each other. Programming is concerned with the optimal allocation of the limited resources. Linear programming is a way to handle certain types of optimization problem. And linear programming is a mathematical method for determining a way to achieve the best outcome. Definition of LP. Mathematical technique used to obtain an optimal solution in resources allocation problems such as production planning. It is a mathematical model or a technique for efficient and effective utilization of limited resources to achieve organization objective. That means we want to maximize the profit and minimize the cost. And when solving a problem using linear programming, the program is put into a number of linear inequalities. Then an attempt to meet, maximize or minimize the inputs. What are the requirements? There must be well-defined objective functions. There must be concentrates on the amount. There must be alternatively course of action. The decision variable should be interrelated and non-negative. Resources must be limited in supply. And now the objective function. First of all, we have to understand the terms which we used in linear programming. First is objective function. A linear function z is equal to ax plus by, where a and b are constant, which has to be maximized or minimized, is called linear objective function. Decision variable. In the objective function, x and y are called the decision variable. Concentrates. The linear inequalities or restrictions on the variable of an LPP are called the linear concentrates. जो हमने linear inequalities में किया था ना 11th class में inequations को, that are the concentrates. And the conditions x is greater than equal to 0, y is greater than equal to 0 are the non-negative concentrates. Next one is feasible reason. The common reason determined by all the concentrates, including non-negative restrictions, is called feasible reason. Feasible solution. Points within or on the boundary of the feasible reason is called the feasible solution. Infeasible solutions. Any point outside the feasible reason is called infeasible solution. Optimal solution. Any point in the infeasible reason that gives optimal value. Optimal value, that means the maximum or minimum value of the objective function, is called optimal solution. And now theorems on the LBP. Let R be a feasible reason. That means the common reason, convex polygon, for an LBP. And Z is equal to AX plus BY, that is the objective function. And when Z has an optimal value, that means maximum or minimum value, where X and Y are subject to the concentrates, described by linear inequalities. And this optimal value must occur at the corner points. That means the vertex of the feasible reason. And now the second theorem. Let R be a feasible reason for a LBP and Z is equal to AX plus BY is the objective function. अब ये जो feasible reason है, ये हमारे पास two types के हो सकते हैं. One is bounded, second is unbounded. If R is bounded, bounded means चारों तरफ से बंद है, then the objective function Z has both a maximum and minimum value of R. And each of these occur at the corner points of the R. And if the feasible reason is unbounded, यानी कि open है, then the maximum or a minimum value of the objective function may or may not exist. If it is exist, it must occur at the corner point of R. And now corner point method for solving an LBP. So first of all, we have find the feasible reason, यानी कि जो हमने 11th क्लास में ग्राफ ड्रॉ किया था, बिल्कुल सेम उसी की तरह से हम ग्राफ ड्रॉ करेंगे, feasible reason फाइंड करेंगे. Determine its corner points, that means the vertices, either by inspection or by solving the two equations of the lines intersecting at that point. Evaluate the objective function Z is equal to AX plus BY at each corner point. Let capital M is the largest value and small m is the smallest value of the Z. When the feasible reason is bounded, M, capital M and small m are respectively the maximum and minimum values of Z. And if the feasible reason is unbounded, and capital M is the maximum value of Z, if open half plane determined by AX plus BY greater than M has no point in common, यानी कि AX plus BY greater than M में कोई भी point common नहीं है with the feasible reason, then M is the maximum value. If there is any common point, then Z has no maximum value. Similarly, if M is the minimum value of Z, if the open half plane determined by AX plus BY is less than M, has no point in common with the feasible reason. अगर किसी भी point के साथ common reason नहीं है, तो हमारे पास यही M जो है minimum value है. Otherwise, Z has no minimum value. Is it clear? And now we have the multiple optimal points. If the corner points of the feasible reason are the optimal solution of same type, optimal, that means the maximum or minimum values, both produces the same maximum or minimum, then any point on the line segment joining these 2 points is called an optimal solution of the same type. Is it clear? And now we have to consider the examples. Maximize this z is equal to 5x1 plus 7x2. यानी कि x1 x के रिप्लेस पर है और y के रिप्लेस पर यहाँ x2 है. Such that x1 is less than equal to 6, 2x1 plus 3x2 is less than equal to 19, x1 plus x2 is less than equal to 8, and x1 is greater than 0, x1 is greater than 0, x2 is greater than 0. यानी कि ये जो पार्ट है, ये जो इनइक्वालिटीज है, इसका ग्राफ ऑलरेडी आप लोगों ने 11th क्लास में ड्रॉ किया था. मेनली हमने क्या करना है, z इज इक्वल टू 5x प्लस 7x को मैक्सिमाइज करना है. m max मीन्स मैक्सिमाइज. एंड नाउ हियर दिस इज x2. एवरी पॉइंट इज इन दिस इज नॉन नेगेटिव क्वाड्रेंट, यानी कि फर्स्ट क्वाड्रेंट है जिसमें हमारे पास दोनों वैल्यूज x और y पॉजिटिव होते हैं. एंड नाउ फर्स्ट यू हैव द इन इक्वेशंस. x1 इज लेस देन 6. दिस इज द लाइन. x1 इज इक्वल टू 6. लेस देन 6, दैट मीन्स ऑन दिस साइड. ओके. एंड देन 0 is less than 6. Shade the region along the origin towards origin. And now this line 2x1 plus 3x2 is less than equal to 19. ग्राफ ड्रॉ किया हमने इसका. ओके. ग्राफ ड्रॉ करने के बाद हमने ओरिजिन के कोऑर्डिनेट्स इसमें सब्स्टिट्यूट किए, यानी कि 2 into 0 plus 3 into 0 less than 19 है. एंड शेड द रीजन अलोंग द ओरिजिन, यानी कि इसका भी हमने इस तरफ ओरिजिन की तरफ शेड करना है. एंड नाउ द नेक्स्ट इक्वेशन इज x1 plus x2 is less than equal to 8. दिस इज द ग्राफ. और इसके लिए भी हमने ओरिजिन के कोऑर्डिनेट सब्स्टिट्यूट किए, यानी कि 0 plus 0 less than 8. शेड द रीजन टुवर्ड्स ओरिजिन. एंड नाउ वी हैव all the equations. x1 is less than 6, this equation, and x1 plus x2 is less than equal to 8. That means this is the common reason. Common reason is called the feasible reason. This reason, we have to shade this reason. And the corner points, vertex A00, that is B 60, and C, that is 62, D, that is 53, and E, that is 0.60 and 6.33 E. ओके. अब ये जो हमने पॉइंट्स हैं, ये जो या तो हम ग्राफिकली इसको देख सकते हैं, कैलकुलेट कर सकते हैं, अदरवाइज हम क्या इन दोनों इक्वेशंस को सिंप्लीफाई करें तो हमारे पास ये पॉइंट ऑफ इंटरसेक्शन आ जाएगा. इज इट क्लियर? और जनरली इसको जो है ना हम ग्राफिकली ही फाइंड करते हैं. एंड नाउ द ऑब्जेक्टिव फंक्शन z इज इक्वल टू 5x1 प्लस 7x2, यानी कि ऑब्जेक्टिव फंक्शंस के अंदर हमने ये कॉर्नर पॉइंट सब्स्टिट्यूट किए. A00 सब्स्टिट्यूट किया, यू विल गेट 0. 60 सब्स्टिट्यूट किया, 5 into 6 plus 7 into 0, that means 30. And 62 सब्स्टिट्यूट किया, that means you will get 44. 53 सब्स्टिट्यूट किया, 46. और E सब्स्टिट्यूट किया तो हमारे पास आ गया 44.33. हमने क्या करना था, मैक्सिमाइज. अब इन Z में से जो मैक्सिमम वैल्यू है, मैक्सिमम वैल्यू इज 46. Maximum value is 46. That means the optimal value is 46. At what point? That means the optimal point is 53. ठीक है. Maximize, maximum value is 46 at 53. Is it clear? Yes. Now we have the second example. Minimize Z is equal to 5x1 plus 2x2 such that 2x1 plus 5x2 is greater than equal to 10. 4x1 minus x2 is greater than equal to 12. x1 plus x2 is greater than equal to 4. And x1 and x2 is greater than equal to 0. First of all, we have to draw the graph for inequalities. Now here the graph. That means here x1 plus x2 is greater than equal to 4. अगर इसमें हम 0 0 सब्स्टिट्यूट करें, 0 plus 0, 0 is greater than equal to 4. That is false. That means we have to shade the region away from this line. And for this second equation, ये जो हमारे पास है 4x1 minus x2, इसमें अगर हम सब्स्टिट्यूट करें 0 0, 0 is greater than equal to 12. That is false. Shade the region towards away from origin. And similarly for this, we have the region is this one. And therefore, the common region is this one. This is the unbounded feasible region. Okay. And now, what are the corner points? The corner points are A, 35 by 12 and 8 by 11. अब ये जो हमारे पास पॉइंट्स आए हैं, ये ग्राफ के पॉइंट ऑफ इंटरसेक्शन है, यानी कि जो ये दो लाइंस हैं, इन दोनों लाइंस का इंटरसेक्शन पॉइंट है. ओके. और ग्राफ आपको एग्जैक्टली बनाना है, क्योंकि ये पॉइंट, ये जो लाइन है, इसका रीजन ऊपर की तरफ है और यह छोटा सा पॉइंट है. अगर आपका ग्राफ सही नहीं होगा तो ये आपका रीजन, आपके आंसर्स भी गलत हो जाएंगे, क्योंकि कॉर्नर पॉइंट्स गलत हो जाएंगे. ओके. एंड नाउ द कॉर्नर पॉइंट्स 35 by 11, 8 by 11. ऑब्जेक्टिव फंक्शन z is equal to 5x1 plus 2x2. इसमें सब्स्टिट्यूट किया, यू विल गेट 191 by 11. एट बी पर क्या है 50, इसकी वैल्यू कितनी आ गई 25. मिनिमम वैल्यू कितनी है 17.365. एट व्हाट पॉइंट 35 by 11 and 8 by 11. And now you have to see the next example. Determine graphically the minimum value of the objective function z is equal to minus 50x plus 20y subject to constants 2x minus y is greater than equal to minus 5, 3x plus y greater than equal to 3, 2x minus 3y less than equal to 12, x is greater than 0, y is greater than 0. So first of all we have to draw the graph for this. These are the graph और हमने ये रीजन शेड किया है. ओके. ये 11th क्लास का वर्क था. एंड नाउ द कॉर्नर पॉइंट्स. दिस पॉइंट इज 0.5. कॉर्नर पॉइंट्स जहां पर लाइंस इंटरसेक्ट कर रही हैं. 0.5, दिस इज 0.3, 1.0 एंड दिस पॉइंट 6.0. ओके. 1.7 और 9.2 दीज आर नॉट द कॉर्नर पॉइंट्स, क्योंकि लाइन के ऊपर है, एक सिंगल लाइन के ऊपर है. कॉर्नर पॉइंट्स क्या होते हैं कि लाइन, एक लाइन और दूसरी लाइन, दो लाइंस जब वो इंटरसेक्ट करती है कॉर्नर्स बनते हैं. अब ये कॉर्नर पॉइंट्स हमने जेड में सब्स्टिट्यूट किए, वी गेट दिस, दैट इज 100, 60, minus 50 and minus 300. Minus 300 is the smallest value. And now we have to check minus 300 is optimum value or not, because this region is unbounded. अभी जो हमने लास्ट किया था वो भी अनबाउंडेड था, उससे पहले वाला बाउंडेड था. ये अनबाउंडेड रीजन है, तो अनबाउंडेड रीजन के लिए हमें चेक करना है कि दिस वैल्यू minus 300 is the optimal value, yes or no. So first we have to suppose minus 300 is not the smallest value. There is another solution. And now we have to draw the graph for minus 50x plus 20y is less than minus 300. And this value minus 50x plus 20y, this is the z. Z is equal to minus 50x plus 20y था. यानी कि this minus 50x plus 20y is less than minus 300. It becomes, and now we have to draw the graph for this. यानी कि पहले वाले रीजन के साथ इसका कोई रीजन, कोई पॉइंट कॉमन है या नहीं है. अगर ये कॉमन पॉइंट है, then minus 300 will not be the minimum value of z. अभी जो हमने किया था ना थ्योरम 2 के अंदर अनबाउंडेड रीजन का, ये वहीं से कंसेप्ट हम कंसीडर कर रहे हैं. ओके. एंड नाउ अगर पहले वाले रीजन के साथ कोई कॉमन पॉइंट है तो सोल्यूशन नहीं है, अगर कॉमन पॉइंट नहीं है तो ये सोल्यूशन है। ओके, एंड नाउ you have to see the graph. This is the line minus 5x plus 2y is less than minus 30. ये हमने डॉटेड लाइन ड्रॉ करेंगे, ठीक है, क्योंकि यहाँ पे हमारे पास लेस देन था, ग्रेट लेस देन था इसलिए, और ये रीजन है शेडेड रीजन, तभी इसको डार्क हमने शो किया है। पहले वाला रीजन ये सारा था, अब वाला रीजन ये है, यानी कि इसके साथ हमारे पास कॉमन पॉइंट्स हैं, तो कॉमन पॉइंट्स होने की वजह से -300 इज नॉट द ऑप्टिमल सॉल्यूशन। इज इट क्लियर? एंड नाउ सी द अनदर एग्जांपल, मैक्सिमाइज z 2x1 plus 6x2 such that 4x1 plus 3x2 is less than equal to 12, 2x1 plus x2 is greater than equal to 8, x1 and x2 is greater than equal to 0. And now for the reason, for the graphically, when we have to substitute a reason, you will get false, shade the reason away from this, and when we have to substitute the coordinates of a reason in this case, we get true and therefore shade the reason towards this. पहले वाला reason इसका ये है, इसका reason ये है, it means there is no feasible reason to exist. Therefore, the problem is not having a optimal solution. Okay, is it clear? Thank you and have a nice day.